Hello everyone, I am Nimay Purohit and today I am going to present my round 2 experiment and the PPT of IYPT Problem 1 Invent Yourself. This is the table of content which includes all the things which I have done in this PPT. The aim of the project is invent yourself. In this experiment we have to take a box and we have to identify accurately the number of matchsticks which are present inside the box only by shaking the box. We also have to find if accuracy depends on the properties of object, the box and the packing density. These are the parameters. In this, the problem asks us to find a way of accurately predicting the number of matchsticks in a matchbox just by shaking it. In other words, it asks us to find the dependence of various properties of sound on various factors. Therefore, the two most important properties of sound were frequency and loudness. And these were the parameters which I considered in the experiment. The many factors which affect the sound are there are two types of factors, quantitative factors and qualitative factors. The quantitative factors are the distance between the sensor and the source, the point around which we shake, the force with which we shake, the size of the matchbox, and the qualitative factors are the manner of shaking, the materials which we are shaking. Therefore, the above factors were considered in the experiment. Experiments were conducted to find the relation between sound and various factors. Initially, I expected that the sound's frequency as well as the amplitude both should depend on the above qualities, quantitative and qualitative factors. So hence I formed an equation by myself in which I considered the variables f, a, d and x where the meaning of the symbols are shown here. A, B, C, D are the dimensions of the respective quantities and I added a few constant by myself to so that the qualitative factors are also covered. Now another factor is the number of matchsticks. Therefore, keeping the other factors constant, we can find the relation between the sound and the number of matchsticks. In this, I considered two cases. When there are a few matchsticks, like say less than 5, and if there are large number of matchsticks about to fill the matchbox. Intuitively, we can say that since the large number of matchstick does not allow much vibration and a small amount of matchsticks, there are less vibrations because the matchstick number is less, we can say that the sound should be approximately the same. So I expected the sound to be a function of both the matchsticks and the volume of air. Since they are both dimensionally different, therefore I decided to take the percentage of the volume of the matchsticks and the percentage of volume of air. So I expected an equation something like this. Keeping the other factors constant, I formed the overall equation. Then I found the value of x such that x times 100 minus x is maximum, and which I got the maxima at x equals to 50. So I expected the maximum sound to be produced about half the matchbox. These are the materials which I used. Three types of matchbox and different matchsticks. The matchboxes are a large one, a medium one, and a small one. The materials required, the measurement was done by an application which is known as FIFOX. You can see here, I have taken a screenshot of this application. For the graphing calculator, I used Desmos. Procedure and observation. Frequency. I did the experiment for a medium-sized box corresponding sized wooden matchsticks. To measure the frequency of sound, I used FIFOX. The materials I tried are shown here. Procedure and observation. Further thought and the experiments prove that frequency does not change even if the factors are changed. Hence, in our equation, the value of a becomes 0 and hence frequency is constant. Hence, we get a new equation on which the only amplitude depends on the factors. B. Loudness. Multiple experiments were conducted to check the factor on which loudness depends. To get accurate values, a device was calibrated to a reference level such that the surrounding sound is assumed to be 0 decibel. I calibrated the loudness scale to 70 decibels to be more accurate. So keeping the keeping all of them constant, I did the experiment for 1 matchsticks in a matchbox and then 5 matchsticks. The different parameters I considered were number of matchsticks, distance between sensor and source, the point around which we shake, the force with which we vibrate, and the materials which are used. Number 1. Number of matchsticks. The number of matchsticks were varied from 1 to 40 with an intervals of 5, keeping the other factors d and x the same. It was observed that an increase in number of matches, the loudness increased for a certain number and then decreased as we predicted. Second, distance between sensor and source, the point around which we shake. The distance was varied and we shook and we concluded that based on the observation that as distance increases, amplitude decreases. Hence, it was concluded that distance also affects the loudness produced. In fact, it is very intuitive that if you go far and shake, then the amplitude which is recorded decreases. The force with which we vibrate. First, the matchbox was shook with less force and then with more force. As expected, the amplitude in the first case was less and the second case it was more. Hence, it is concluded that loudness depends on the force with which you vibrate it or the amplitude of vibration. The materials which are used. The two types of materials were used, matchsticks and small plastic sticks. As expected, the loudness varied, keeping all the other factors constant. Hence, the loudness, like frequency, depends on the material used. So it was finally concluded that A raised to B is proportional to x times 100 minus x into d raised to the power c into x raised to the power d. Note, there are many other factors which may not have been considered and any correction is welcome. Here are the results. Frequency. The frequency was the same for both experiments when the matchstick was 1 or 5 matchsticks. This is because it is similar to friction and it is the property of the materials and not the number of matchsticks. Experiment was tried for a plastic matchstick with the same matchbox and I got the same results. Loudness. With an increase in number of matchsticks, the loudness increased for a certain number and then decreased with some slight inaccuracies. As the distance between sensor and source increases, the amplitude decreases. The loudness depends on the force with which we vibrate. Loudness, like frequency, depends on the materials used. Frequency. This is one measurement which I took where we can say the most data points were of 1995 Hz. A measurement of frequency by Fox. It can be seen that the frequency readings remain almost constant. Loudness versus number of matchstick graph for a small size matchbox and matchsticks. This is the graph which I got. We can see that it almost looks like a parabola and we get a highest peak and then it slowly decreases. I have attached the link in case if we want to see the data points. This is the graph for a medium size matchbox and matchsticks. Similar to the small size, it looks like a parabola. First it increases, then after some time it decreases. This is the graph for a large size matchbox. Since the large size matchbox has a large volume, hence there are high chances of error and hence the graph is not a perfect parabola. In this case, it is slightly different than a parabola. Conclusion. Frequencies remains the same for any number of matchsticks. Loudness depends on the number of matches as readings are different with different number of matchsticks. Loudness also depends on the distance between the source and the receiver. As with increase in the distance, loudness changes. Loudness also depends on the force of vibration as when it was shook with less force, the loudness decreases. Loudness depends on material. As with change in material, loudness also changes. Precautions and sources of errors. For getting accurate values, we have to calibrate the device such that the reference level should be 0 of the surrounding. However, there are some errors due to in frequencies due to matchstick interactions sound is produced and due to matchsticks and matchbox interactions, so there are two sounds produced and we can get confused if we are not careful about it. Let's say I have two matches. Now if I shake the box, we have to consider many factors like number of collisions between matchsticks with each other in a shake, time difference between matchstick and matchbox collision, and many more factors which can lead to errors. These are the references and this is the video which I uploaded on my YouTube channel. Thank you.